What a neuron actually computes. The 3 steps inside every artificial neuron.
A neural network can have billions of parameters. It sounds impossibly complex, but it's built from one tiny unit, repeated, the artificial neuron. And a single neuron does just 3 small steps of arithmetic. Let's open one up.
A neuron receives inputs, numbers from the data, or from other neurons. Each input is multiplied by a weight. The weight is how much that input matters. A large weight amplifies it. A weight near 0 ignores it. A negative weight pushes against it. These weights are what the network actually learns.
The neuron adds up all of those weighted inputs into a single number. Then it adds one more value, the bias, a constant that shifts the result up or down, setting how easily the neuron fires. That's the whole linear part. Z equals the sum of weight times input plus the bias.
But a sum of multiplications is just a straight line, and stacking straight lines only ever gives you another straight line. So the neuron passes Z through an activation function, a simple nonlinear curve. ReLU, for example, keeps positive values and zeroes out the rest. This one nonlinear step is what lets networks bend and model the real world.
Here it is end to end. A neuron judges whether an email is spam from 2 clues, how many links it has, and how many trigger words. Multiply each by its weight, add the bias, and you get Z. Squash Z into a number between 0 and 1, and that's the neuron's answer. Here, a confident 91%. Spam.
So that's all a neuron is. Multiply, add, activate. Nothing more. The magic isn't in the unit. It's in wiring millions of them together and tuning every single weight until the whole network gets the answer right. And how it tunes those weights is exactly where we go next.